Hiya tens, so this video is on true bearings. So you will find this part of the chapter is not in your booklets, but I still think it's important that we go through it, and I will upload a worksheet because bearings do come into a couple of the topics in maths, and it's just a good idea just to understand how they work. So a direction can be described by comparing it with the true north direction, and that's what we call a true bearing. There are different types of bearings, but we're only going to focus on true bearings. So a bearing is the clockwise measure from the north and written using 3 digits. So a little diagram there. The bearing of A from B is 252 degrees. So when it says the bearing of A from B, it means we're measuring the angle at B from north all the way around to the line that joins B to A. And you'll see that's 252, and it always goes clockwise round. And then the bearing of B from A is 072 degrees. So as I said, you have to write it using 3 digits, so we put a 0 out the front. And B from A, which means we're wanting to find the angle near A. So we see our A there, it's from the north of A, all the way down to the line that joins A to B. So if anything, people just get confused with that wording. Alright, we're just going to do 2 examples. So the first one, we've got starting from A motorbike travels 7 kilometers east to B, then 3 kilometers south to C. Find the bearing of C from A. So we need to draw a diagram. Just like we do with problem solving, we have to draw diagrams for these situations. So we're going to start at A. So we're going to need to draw a point that is A. So I'm going to say A is here. The bike travels 7 kilometers east. So if you don't know what north, south, east and west, I'll just do a quick thing here. So you've got north, south, east and west. So it's going to travel 7 kilometers east to B. So it's going in the east direction. So that's point A to a point B. We know that's 7. Then it travels 3 kilometers south to C. So from B, it's going to go 3 kilometers south to a point C. So we want to find the bearing of C from A, which means we want the angle from A. So we need to draw a nice lovely north at A, because that's where we're going to measure our angle from. And we want the bearing of C from A. So we want to take the angle from that north down to a line that joins A and C. So what we need to do is we need to join A and C together. So our angle is going to be from the north of A, and it's going to go all the way down to the line that joins A and C, like that. Now to work this out, we've got to look at a diagram. This is why diagrams are really important with bearings. And you'll see here between north and east, that's going to be a right angle. So we know we're going to have 90 degrees there. And so we just need to find the bit between the horizontal at B and the line. So I'm just going to do a little bit of shading. So we need to find this angle here. And this is where we use our trig. So look at what we know. In this triangle, the right angle will be here. We want to know that angle there. So if we look, we'll find that we know the opposite and the adjacent. We don't know the hypotenuse, which is the side opposite the right angle. So we know it's going to be tan. So we know it's going to be tan of the angle equals opposite, which will be 3, divided by the adjacent, which is 7. Now we do the inverse of tan so we can find what our angle is. So tan -1 of 3 over 7. Put that into your calculator and you're going to get 23.2 degrees. Now that's just that little bit there, okay, from the horizontal down to the line. But we also need to add the 90 degrees back in, so we're going from north. So that means our bearing will be 90 plus 23.2, which will give us 113 degrees. So with bearings, we very rarely write decimal points. You always just round to the nearest angle. So when we do that, we'll get 113 degrees. All right, next example. So we have a rally driver travels on a bearing of 145 degrees for 28.5 kilometers. How far east of the starting point is the rally driver? So we need to draw a diagram. So we need a point where the rally driver is starting. I'm going to say the rally driver starts here. and he travels on a bearing of 145 degrees. So you've got to remember our bearing always starts from north and it's going 145 degrees. So if you work out where 145 degrees is, it's going to be somewhere in here. So he travels down here for 28.5 kilometers. All right, and then we know that this full angle there is 145 degrees. Now the question is asking how far east of the starting position is the rally driver. So you want to know how far this way is the rally driver. So what you'll be able to see here is that we can make this a right angle triangle, which of the right angles will be here. And then because this whole angle is 145 degrees, because we want to know how far east is, to find that out the angle in this middle bit here that I'm just shading, we can do that by working out the angle is going to be 145 minus 90, because it's 90 between north and east, which will give us 55 degrees. So we know the angle, we know the hypotenuse, and we are wanting to find the adjacent. We want to find how far east. So we're going to use cos. So we're going to have the cos of 55 is going to equal the adjacent divided by the hypotenuse. Rearrange that, so we're going to get 28.5 times the cos of 55 equals x. Work that out. We're going to get that x is equal to 16.3 kilometers. And I've just rounded that to 3 significant figures. So that's how bearings work. Always draw a diagram with bearings. Otherwise, you need to be able to visualize these things. And so what you can do with this is now complete the worksheet that I've posted on my QA, just so you can have a practice of these types of questions.